So good morning, everyone, and welcome to this session where we are going to talk about the AWS well-architected framework. My name is Yolanda Fetela Ntam, and I am going to be your instructor for today. So it's going to be a well-architected framework. It's going to be the well-architected framework at an introductory level so that you understand what the well-architected framework is all about. What are the benefits? You have to understand the core principles outlined in the framework. What is the intent of the framework and the well-architected tool? At the end of this presentation, we are going to look at some sample exam questions and answers if we have time. So what is the well-architected framework? After designing and reviewing thousands of customers' architectures on AWS, they have identified best practices and core strategies for architecting systems in the cloud, which they call the well-architected framework. And this framework helps you to understand the pros and cons of decisions you make while building systems on AWS. And using this framework actually helps you to learn architectural best practices for designing and operating a secure, reliable, efficient, cost-effective, and sustainable workloads in the AWS cloud. It also provides a way for you to consistently measure your architecture against best practices and identify areas for improvement. And the well-architected framework is based on 6 pillars. But before we focus on the 6 pillars of the well-architected framework and the design principles, what will primarily help us is a little bit of history. So while AWS technology actually started in 2006, the well-architected framework started in 2012, when solutions architects realized some recurring architectural problems with their customers and started looking for ways that AWS could help them solve these problems. And so they came up with the idea of just going to customers and asking them if they were well architected. And so in 2013, there were a lot of different questions being asked by solutions architects to their customers. And over the course of time, AWS realized that they needed to be more consistent in the way they were asking these questions. And so in 2014, they came about these questions being based across 4 pillars, originally being security, reliability, cost optimization, and performance efficiency. In 2015, AWS realized that not all customers had access to the well-architected framework, and so they decided to publish the framework in the form of a white paper that sort of incorporated all the best practices that they had learned from carrying out thousands of reviews with their customers. And then in 2016, they added the operational excellence pillar. In 2017, they made sure that AWS partner networks could become trained to deliver the same level of value as solutions architects were delivering using this framework as well. And then in 2018, they actually released what we call the well-architected tool, which you can use in the management console to review your architectures for free. So AWS gives not just the framework for reviewing your architectures, but the tool for doing that process as well. And along with this tool, what they realized is that their customers did not just want to know what AWS's best practices are, but that if they had to use this tool to review their workloads and identify areas that needed improvement, how should they go about it? And so that is how they ended up with this tool, embedded with some improvement plans to help their customers in that regards. And then in 2019, they had some regional launches. In 2020, they had some major updates across all of the pillars. And lastly, in 2021, AWS added the sustainability pillar. So all of this, the main important take home here is that the well-architected framework is based on AWS's long history of working with customers to actually help them understand what they were doing and what was working for them. And so the best practices that we talk about here evolve and change over time. It's always about looking for the best way to build a system, looking at what is working, looking at new technologies and how things are actually evolving, looking at different practices and patterns and building all of that into the well-architected framework. And that is why you can clearly see that they started with questions. And then in 2014, they were basing these questions on 4 pillars, which we mentioned: security, reliability, cost optimization, and performance efficiency. And then in 2016, you can see they added the operational excellence pillar. And then in 2021, we had the sustainability pillar. So you can see the evolution of the framework. So it keeps on evolving as time goes on. So what really is the well-architected framework? So it is made up of 6 pillars, as we know. And the 6 pillars are cost optimization, reliability, operational excellence, performance efficiency, security, and sustainability. And just a fun and simple way to remember these 6 pillars, because they are very, very important for your exams. So you can think about them as crops with S at the end. So C would stand for cost optimization, R will stand for reliability, O will stand for operational excellence, P will stand for performance efficiency, S for security, and S for sustainability. So I'm going to lay a lot of emphasis on these 6 pillars because it is really, really very important for you to commit to mind these 6 pillars as you prepare to take your certification exams and really when you're working in a real life scenario. So by way of analogy, when you're building technology solutions, it's a lot like when you're constructing new buildings. When you're building, that foundation really needs to be strong, right? Because if the foundation is not strong, that building is not going to be safe and usable to deliver what it was constructed for. And so in a very similar way, when you're building technology solutions or you're developing a software, if you neglect the 6 pillars that we have highlighted, then it can become challenging for you to build a system that can deliver on your expectations and requirements. So just to emphasize how important these 6 pillars are. And so these 6 pillars are actually designed to help you build a strong foundation for all of your workloads, identify any issues through consistent measurements against AWS best practices, and help you to mitigate or reduce risk before you actually start producing, delivering to your customers. And we do have some concepts around these pillars. We are going to be looking at them in some detail in the course of this session. Again, what really is a well-architected framework? By way of definition, you can say that it consists of key concepts, design principles, architectural best practices for designing and running workloads in the AWS cloud. And all of this will help cloud architects build a secure, high-performing, resilient, efficient, and sustainable infrastructures for their applications and workloads based on 6 pillars. And again, we always try to come up with a short way to help you remember what is really, really, really important. And in this case, we have KDA. So K here would stand for key concepts, D will stand for design principles, and A would stand for architectural best practices for designing and running workloads in the AWS cloud. So remember, the first one was crops for the 6 pillars. And now we have KDA for the definition of the well-architected framework. So what are the benefits of the well-architected framework? We have 4 major benefits. So AWS actually wants to help their customers to build and deploy faster. And the way that works is that they want them to actually reduce their firefighting efforts and think about things like capacity management, automation, and security that will enable them to experiment and release more often. they don't want customers to focus on fixing things. Rather, they want them to actually focus on their customers. They want them to focus on delivering value for their businesses. And also, one of the ways that happens is that they will help customers to actually identify risk in their environment and then help them to reduce or mitigate this risk before they actually affect their businesses in a negative way. And as such, when they understand what risks are around their environments, they will be able to make informed decisions using data around those risks on how to improve anything that they might want to improve in their workloads or in their environments. And you realize that when you use the well-architected framework, what you're actually doing is that you learn AWS best practices for designing and operating workloads in the AWS cloud. So just to recap, the 4 major benefits would be build and deploy faster, lower or mitigate risk, make informed decisions, and learn AWS best practices. So here we have a question just to make it, interactive and to track if you are actually following up. So it's a question, which of the following are the benefits of using AWS well-architected framework? Select 2. A, build and deploy faster. B, lower or mitigate risk. C, make quick gut-feeling decisions. D, learn advanced programming techniques. E, use the most advanced database technologies. So anyone can answer, please. Okay, Edwin says A and B. Divine says A and B. Is there any contrary opinion? Or can a third person really confirm that it's A or B or A and B or A and C? Okay, Lawi says A, B. Okay, we are good to go. So apart from this, are there any questions? Do you need any clarifications? Okay, silence means we are good to go. So the well-architected framework is made up of 3 major components. So we have the 6 pillars that we already saw. We have design principles that we saw in the definition. And there are 2 types of design principles. We have the general design principles, and these principles are applied across all of the 6 pillars. So these general design principles will be seen across cost optimization, reliability, performance efficiency, security, all of those 6 pillars. And then the second type of design principle is the pillar-specific principle, which is applicable to a specific pillar. So the difference is that one is general, that you would apply across your entire design, and the pillar-specific principles are principles that apply only to each pillar, so they are different. And then we have questions. These questions are actually designed to help you look at the best practices and the design principles and to see if you're following them. And if you're not following them, what risk do they present? And how should you go about solving these problems? How should you go about mitigating this risk? So we are going to look at the pillars. So here, when you deploy your architecture on the first day, that's not all about it. So what matters next is, how is this architecture operated and maintained? And that is what the operational excellence pillar is all about. So it is the ability to support development and run workloads effectively, gain insights into operations, and continuously improve supporting processes and procedures to deliver business value. So for the security pillar, how important is security? Security is all about keeping confidentiality, data integrity, managing user permissions, and establishing controls to detect security events. And so this pillar focuses on the ability to protect information, systems, and assets while delivering business value through risk assessments and mitigation strategies. For the reliability pillar, what you should think about is, what steps have you taken to ensure that no matter the event, your systems can still run as needed? How can you quickly recover from failure? And how can you design for reliability? For example, we have, most airplanes are designed for reliability with at least 2 engines on them. And the intention is that if one engine fails, then that plane should continue to fly using the other engine. And so the reliability pillar here is the ability of a workload to perform its intended function correctly and consistently when it's expected to. And this includes the ability to operate and test the workload throughout its entire life cycle. For the performance efficiency pillar, the question you should always ask is it fast enough to meet the expectations of your users? So in our daily lives, when you go to a website to buy something, what happens is that when you click on the search bar, if there is latency, that website keeps on spinning and spinning and spinning. And most of the times people get frustrated and shut it down and they go to buy somewhere else. So as a business owner, you would want to make sure that customers should not go somewhere else to buy. So you would want to make sure that your website performs so well. In a similar way, now we hear this talk about Black Friday. You should be asking your questions. Can your system scale enough to actually accommodate all the requests that are coming in? So that is very important for performance efficiency. And it is the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. For the cost optimization pillar, so just like anything else in life, AWS has taxes and fees for their services and infrastructure. And so the cost optimization pillar is you're always asking yourself this question: can I make it cheaper without impacting performance? And this pillar focuses on the ability to run systems to deliver business value at the lowest price point. We all know that in our daily lives, when you leave your home, it is normal practice that you should actually reduce your room temperature and turn off the lights, because that has an impact on your gas and electricity consumption, right? And hence your energy bill. But surprisingly, in the cloud, most companies are really not consistently applying this particular concept when it comes to their cloud spending. So that is why the cost optimization pillar here is going to give you tips, design principles, and best practices on how you can really avoid unnecessary costs as you build and manage systems in the cloud. For the sustainability pillar, there has been a lot of talk about the climate change and the weather. And this pillar focuses on the ability to minimize the environmental impacts of running cloud workloads so that AWS can tell you what your carbon footprints are and how you can help to reduce them. Again, we have another exercise to actually see if we capture the concepts around the 6 pillars. It's very, very important that you grasp them. So we have column A and we have column B. So what you have to do is you have to match either one to A, B, C, D, or E. So let's begin with operational excellence. What does it stand for? Does it stand for support development and run workloads efficiently? Is it protect data systems and assets? Is it C, enable a workload to perform its intended function correctly and consistently? Is it D, use computing resources efficiently to meet system requirements? Is it E, run systems to deliver business value at the lowest price point? You can either shout out the answer or you can send it in the chat. So Kinwe says 1 is D. And then Giselle says 1 is D. Edwin says 1 is D. Okay. I think 1 is support development and run workloads efficiently. It's not D because D is something else. And so what is security? Let's move to the second one. Okay, can you say security is B? Any more answers to what is security? I think security is self-explanatory. Maureen says security is B. Giselle says security is B. Okay, we can move on, that's correct. And what is cost optimization? So for cost optimization, I have 2 E's. Okay, we are good to go. And then what is performance efficiency? Now you have to make the difference between performance efficiency and operational excellence. So what is performance efficiency? Edwin says is D, Divine D, Kinue D, correct. And reliability, what is reliability? Reliability is C, 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 correct. Yeah, we are good to go. Thank you very much. So here are the answers. So we have operational excellence is A, security is B, cost optimization is E, performance efficiency is D, and reliability is C. So just to clarify a little bit between operational excellence and performance efficiency, remember we said operational excellence is the ability to support development and run workloads effectively, gain insights into operations, and continuously improve supporting processes and procedures to deliver business value. And here I gave an example that when you deploy your architecture on the first day, that's not all about it. And that what really matters is how is that architecture operated and maintained, right? And here with performance efficiency, we talk about the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. And that is where I gave the example of when you go to a website to buy something and it is slow. So I hope now we get the difference between operational excellence and performance efficiency. So just to clear that up, does anyone have any doubts? Okay, we are good to go. So remember I said there were 3 major components of the well-architected framework. We said we had pillars, we have general design principles and pillar-specific principles, and we have questions. So now we are just from handling the pillars and the concepts around those pillars, and we are going to look at the general design principles. So for the general design principles, we have stop guessing capacity. In the cloud, we can actually dynamically and automatically change the resources associated with the services we use. So we don't have to guess how much resources we need to run our systems, and then maybe find out later on that we were wrong. If we are wrong in the cloud, it's not so much of a problem because we can easily adjust. So what we can do is we can monitor our systems using CloudWatch, and you can use EC2 auto scaling to scale your systems up and down as demand changes. So it's not like in an on-premises environment whereby you are likely to guess how many servers you need to run your workloads. And you may discover that you either bought too many servers or you do not buy enough servers. So what do you do in that situation? It becomes a little bit tricky. So with cloud computing, you actually have resources that will help you scale up and down as required, because the cloud provider is there to manage that capacity for you in the background. If you need 100 or you need 1,000 servers, you should be able to have them when you need them. So that's the major difference. It makes it's very easy in such a way that you don't really have to provision your resources upfront to handle peak levels of business activity. What happens is that you actually provision the amount of EC2 instance that you need, and then you can scale it up and down as demand changes. So that's what we mean by stop guessing capacity. And then for the second general design principle, we have test systems at production scale. So the cloud makes it really easy for you to set up a whole new environment with a lot of resources using services like CloudFormation that allows you to spin up environments within minutes, complete your testing, and decommission all of those resources. And you're going to pay only for the time that that environment is running. So it's not so expensive to do that compared to what it takes for you to test systems in an on-premises environment. And this actually lets you to test your systems at production scale. So testing should actually be used and really encouraged in your environments to test systems before you deploy them and find out what could fail. And then we have automate to make architectural experimentation easier. So the cloud allows you to create and replicate your workloads at a low cost and at the expense of manual effort. So rather than you using a manual process to build your infrastructure, you should be using CloudFormation that actually allows you again to automate the deployment of your infrastructure as code. In that way, you're going to actually make these experiments to be easier, to be quicker, and you're going to enable a consistent response to events. Allow for evolutionary architecture. So in a traditional IT environment, architectural decisions are often implemented as static one-time events. And in the cloud, you would notice that architectures change over time. It's not like in an on-premises environment where a particular architecture is being used. For example, if your application uses EC2 instance and runs 24/7, if that makes sense, you can actually replace that EC2 instance with AWS Lambda. And in a similar way, you know that AWS also releases a lot of services and resources that actually helps you to do things in a better way, in a more cost-effective way, and in an easier way. So when you're designing your architectures, make sure that you allow room for evolutionary architectures, you make room for changes. And this boils down to the same thing here that we say, drive architectures using data. In the cloud, you can actually collect data on how your architectural choices are affecting the behavior of your workloads. And this will actually enable you to make fact-based decisions on how to improve your workloads. We know that data provides a lot of insight in everything we do. And when you deploy your architectures on the first day, you don't have this data. But as you start operating, you can collect data to see how your resources are working. And if that makes sense, you can actually make some changes. So having your architectures deployed on the first day does not mean that you are done and that you will never actually change or modify it. So we have also, you can improve through game days. So what are game days? Game days are actually events where you can try out things like disaster recovery. You can test your architectures to be sure that they are actually working well. So in terms of disaster recovery, for instance, you can test to see what happens if one of your regions goes down or if one of your availability zones goes down, so what happens? So on such a day, you are actually testing and actually performing failover exercises. And this actually helps you to identify where you can make improvements, and it helps you to develop organizational experience in dealing with events. Is it clear? Hello? Is it clear? Can I hear someone say something?
Yes, it's clear.
It's clear. Okay, good. We are good to go. Thank you. And now we are going to look at the pillar-specific designs. And what you would note here is that there are a lot of overlaps of services and methods for each pillar. And the recommendations you see for one pillar can also be used for another pillar. For example, you will notice that services like CloudWatch and CloudFormation actually occur over and over again in the different pillars. So now we are starting again with operational excellence, but now we are looking at the pillar-specific design principles. Previously, we looked at the concepts around all of these pillars, but now, again, we are looking at the pillar-specific principles for each of those pillars. And just as a reminder, the operational excellence pillar is the ability to run and monitor systems to deliver business value and to continuously improve supporting processes and procedures. So what are the design principles? The first one is perform operations as code. So don't perform operations manually. Use tools like CloudFormation that actually allows you to automate the deployment of your infrastructure as code. And when you perform operations as code, you do things in a quicker way. You limit human error because you are not clicking through the management console to provision things, and you enable a consistent response to events. And then make frequent, small, and reversible changes. So rather than make big changes that are difficult to roll back, make smaller changes that if something happens, you can roll back and try that again without affecting customers where possible. And then you have, when you're using operation procedures, make sure you constantly look for opportunities to improve those procedures. As you evolve your workloads, evolve your procedures appropriately, and you can actually set up regular game days to review and validate that all of your procedures are effective and that the teams are familiar with them. It's not going to be fair for you to have a very good procedure and your teams are not really aware of them. They don't know how to use it. So as we said, game days are days where you can test for things like disaster recovery. You can also test for things like procedures that you're using in your environment. So make good use of those particular aspects. And then anticipate failure. So make sure you always anticipate what can go wrong. Nothing works at 100% because that is how you can actually prevent it from happening. Again, set up regular game days to test workloads and team responses to simulated events. It's going to be very helpful. And then if something fails, if something breaks, or if you make a mistake, make sure that you document that and learn from it so that you don't have to make that same mistake again. Work out, why did this thing happen? How can I do it next time so that, you know, I should not be making the same mistakes over and over again. Take the lessons out of that experience and share them with the rest of the teams so that they too can benefit and avoid making such an error next time. So that is what anticipating failure and learning from all operational failures is all about. And the major services for the operational excellence pillars would be CloudFormation that enables you to deploy your infrastructure as code. You have CloudWatch for monitoring, and you have AWS Config for auditing and evaluating configurations, just to make sure that things are being tracked. We have other services, but these are just the major services when it comes to operational excellence. And then the next pillar here is security. As we said, security is the ability to protect information, systems, and assets while delivering business value through risk assessments and mitigation strategies. And remember, we said security is all about providing confidentiality, data integrity, managing user permissions, and actually establishing controls to detect security events. And so for the design principles, we have implement a strong identity foundation. So implement the principle of least privilege. I'm sure you have come across this particular phrase here. Give users access only to what they need with appropriate authorization to interact with each of your AWS resources. So for example, you should not give a developer access to all of your S3 buckets when he actually needs access only to one of your S3 buckets. That is what we mean by implement the principle of least privilege. And avoid using long-term credentials. Use IAM roles wherever possible. So for example, if you have an auditor that has to come to your account once in a while to do something, rather than giving him a username and a password, you should give that auditor, for instance, an IAM role because it is short-term. It's a short-term credential. And so the second aspect for security is enable traceability. And this can be achieved by actually monitoring, alerting, and auditing actions and changes to your environment in real time. So for monitoring, you would use things like, for example, CloudWatch. You heard about CloudWatch yesterday, I think. Alerting, you have SNS, and auditing, you have AWS config. So that will enable traceability in your environments. And then we have apply security at all layers. So what you should do here is you should be able to add the best security that your application needs at each level. For example, you can use the web application firewall to filter application traffic. You can use the VPC network access control list to control traffic at the subnet level. You can use security groups to control traffic at the instance level. And you can use AWS Shield for distributed denial of service at the edge locations. We have automate security best practices. So automate as much as you can. The more you automate, the less human errors you're likely to have. So use tools like CloudFormation to deploy your infrastructure as code. And you can use AWS Lambda to react to events as they happen. So in our on-premises situation, you might have a one security engineer who is there and he's in charge of, responding to security events when the alarm goes off. And if an alarm goes off in the middle of the night, for example, he has to jump up and he has to do the necessary to help address that particular situation and mitigate that security incident. But there's a problem there having that security engineer waking up in the middle of the night because he might not be optimal. We know how that feels if you have to wake up in the night to do something when you were sleeping and the alarm goes off. So when you automate all of these security best practices, this actually takes off the load, the burden, and the stress. And it allows you to have a consistent response to all of the security incidents. Protect data in transit and at rest. So here, think about encryption. So you might actually want to encrypt your data as it travels across on your website in transit, as well as data at rest when it is stored in a database or in a storage system. Keep people away from data. So reduce or eliminate the need for direct access or manual processing of data, because this reduces the risk of mishandling or modification and human error when handling sensitive data. And then lastly, prepare for security events. So in case something happens like a malicious attack or a distributed denial of service, make sure you have a plan. Make sure you have an incident management and investigation policy and processes that actually align to your organizational requirements. And the major services for the security pillars here are, we have identity and access management. You saw that when you did security with ACO. We have key management service that you will use to encrypt your data address. We have CloudTrail to actually track all the API calls, who did what in your account at what time. We have the web application firewall to filter the web application traffic, and we have many other services that will actually help in terms of the security pillar. For the reliability pillar, this is the ability of a system to recover from infrastructure and service disruptions, dynamically acquire computing resources to meet demand and mitigate disruptions such as misconfigurations or transient network issues. So for the design principles, we have automatically recover from failure. So make sure that when something goes wrong, like a system fails, you can automatically recover from failure with no manual effort. And in this case, you should be thinking about EC2 auto scaling. If an EC2 instance fails, EC2 auto scaling automatically replaces that instance, and your load balancer starts distributing traffic to that particular instance. So that is what we mean by automatic recovery. And then test recovery procedures. So the cloud makes it easy. We already saw this. It makes it easy for you to set up a whole new environment using services like CloudFormation. And what they have noticed over time is that most companies don't test their recovery procedures until they really need to do that. And then they find out that it's not working when it's already too late. So you should really actually pay attention to that, testing your recovery procedures, using game days to actually perform failover exercises, identify areas that need improvement in your environment, and develop that experience in dealing with, any bad thing that can happen, such as a disaster. Scale horizontally to increase aggregate workload availability. So with this, we mean that you should replace one large resource, it could be an EC2 instance, with multiple small resources to reduce the impact of a single point of failure on the overall workload. And you should distribute traffic or requests across multiple resources to ensure that they don't share a common point of failure. For example, where you have EC2 instances, it's always advisable to scale them horizontally so that the failure of a single component will not impact your entire application. So that's what they mean by scale horizontally to increase aggregate workload availability. And if you do that, it's going to actually increase the reliability of your systems and your workloads. Stop guessing capacity. I think we already talked about this when we're looking at the general design principles. Manage change in automation. So changes to your infrastructure should be done using automation. It should not be done manually. Again, this means that you should not be clicking through the management console to actually provision things or to make changes. Do all of this by automation because this will actually help you to do things in a quicker way, and it's going to limit human errors. We all know that as humans, we are prone to making mistakes. So to avoid all of those mistakes, what we should do is we should actually use more of automation than, manual efforts. And then performance efficiency. The design principles here, you have democratize advanced technology. So what they mean here is that AWS wants you to leverage the technology and services that they provide. And so they are saying that rather than asking your IT team to learn about hosting and running a new technology, consider consuming the technology as a service because this provides value to your business. They provide a lot of amazing tools, such as managed services, event-driven architectures, serverless services, and all of this will actually help you to focus on your customers and on your business logic rather than managing, servers in the background. And then we have go global in minutes. We all know that AWS has a global infrastructure, which is made up of regions, availability zones, and edge locations. And you can use this infrastructure to deploy your applications to multiple physical locations with just a few clicks. When you place your applications closer to your customers, latency is reduced and they are going to actually enjoy their customer experience because it's going to be faster. And then we have the third one is use serverless architectures. And serverless architectures remove the need for you to run and maintain servers again, so that you can actually focus on your business logic and your customers rather than managing servers. AWS recommends you use serverless architectures. There's a lot of talk about serverless out there. And then experiment more often. The more you experiment, the more you learn from what you do, and you're going to be able to improve your processes, performance, and operations. And then the last one for the performance efficiency pillar is consider mechanical sympathy. So this means that you should use the technology approach that aligns best with your workload goals. For example, you should consider data access patterns when you select a database or a storage approach. So if you want to, you need access to your data immediately, rather than save your data to Amazon Glacier, for example, it's going to be quite tricky because there you need to wait for 5 minutes. Even when you have the expedited option, you have to wait for 5 minutes before you can get your data back. And normally it's even 5 to 7 hours for you to get your data back. So when you're choosing a database or a storage system, make sure that you look at those approaches in order for you to be able to build a more, a performant environment. And the major services here are, again, we have CloudWatch for monitoring. We have CloudFront for content delivery. We have Elastic Cache to actually cache your recently accessed queries, and we have auto scaling. For the cost optimization pillar, we said it focuses on the ability to run systems to deliver business value at the lowest price point. So for the pillar-specific design principles, we have adopt a consumption model. So pay only for what you use. Pay only for the computing resources that you require. For example, with AWS Lambda, you actually pay only for the running time. Measure overall efficiency, measure the business output of the workload and the cost associated with delivering it, and use this measure to know the gains you make from increasing output and reducing cost. We have stopped spending money on data center. So remember that we said the cloud allows you to trade capital expense for variable expense. So rather than managing and maintaining powering servers, you should actually, take advantage of what the cloud gives you and focus on your business project rather than on IT infrastructure. Analyze and attribute expenditure. So we have the cost explorer here that has a dashboard that actually shows you your total bill and the particular resources in your infrastructure that are consuming more, which enables you to figure out what to do about it. We have use managed and application level services to reduce cost of ownership. That goes down to using managed services such as RDS, for instance, where you are not maintaining and managing servers. And so AWS does that for you, and you actually reduce the cost of ownership because you are not paying someone to do that for you. And for the major services, we have the Cost Explorer. We talked about it already. We have tag resources. So you tag your resources, you can tag your projects, and you filter them by projects to make sure that you can identify which project is costing more. And then we have auto scaling. We talked about auto scaling. And for the sustainability pillar, we said that this pillar was added last year at the AWS reInvent. And the purpose of the pillar is actually to minimize the environmental impact of running cloud workloads. And these are the design principles. I think I am going to leave that for you to check on this as your homework. So I will just outline them. Here you have design principles, understand your impact by establishing performance indicators, establish sustainable goals, maximize utilization, which means that you should right-size each workload to maximize the energy efficiency of underlying hardware and minimize idle resources. And you should also anticipate and adopt new, more efficient hardware and software offerings. We all know that when you use this new technology, it's designed in a way that it will actually reduce your carbon footprint. So that is what is recommended here under the sustainability pillar. So to know more about this pillar, you have to click on this link and read more about that. So that's the 6th pillar of the well-architected framework, which was added recently in 2021. So is there any question? Are there any questions, please? The house is so silent.
Yeah, that's right. So silent. I means they're getting it.
Perfect.
Or they're trying to swallow, digest it.
No, the question because I enjoy the classes.
Really? Okay. So we are good to go. So again, just a recap of what we said. We said there were three major components of the well-architected framework. We already spoke about the pillars and the concepts around those pillars. We spoke about the design principles. We looked at the general design principles and the pillar-specific principles. And now we are going to look at the questions. And remember, we said that questions are designed to help you look at the best practices and design principles and to determine if you're following them. And if you're not following them, what are the risks that you're exposed to? And how can you actually address or mitigate those risks? So with questions, each pillar of the framework is comprised of a set of 8 to 11 questions organized into best practices areas. And we have one of the questions here from the reliability pillar. And if you take a look at the general structure of the question, you have one. It starts with the area that it comes from. And this particular question is from the failure management area of the reliability pillar. So all of the pillars are broken up into best practice areas. And this particular question is from the failure management area of the reliability pillar. And below that question, the best practice area, we have the question. And the question here is, how does your system withstand component failures? Underneath that question, we have some context. And this context here is designed to help you understand how this question relates to you and what would you think about it in your environment and against your workloads. So the first one thing that we have to note in terms of the structure of the question, we have the area, the best practice area, which is one. And then we have the question. The question, we have the context. As you can see here, this blue line, it indicates the next section. So we have one, failure management. We have two, we have two, which is the question and the context. And then we have the best practice area. So the best practice area here is a list of best practices that AWS encourages you to implement in your environments. So reflect a little bit on that question. How does your system withstand component failures? And then you have an explanation of what that question is all about. And here you have the recommendations that AWS gives you. For instance, monitoring is done at all layers of the workloads to detect failure, deploy to multiple availability zones, multiple AWS regions if required, has loosely coupled dependencies. So these are the best practices. So for a recap, the three things we have to note here when it comes to questions. Questions are designed to help you look at the best practices and the design principles to help you determine if you are well architected, and if you're not well architected, what risks do they present and what should you be doing to help solve that particular problem. And then in terms of the structure of the questions, think about these three components we have talked about here. The best practice area, these are the key components and topics of the specific pillar and how the questions are organized. Think about the question and context section. Here you will find the question and some context to help you understand it. And then we have the best practices area. The best practices are approaches, processes, and methods that have been shown to lead to good outcomes based on the questions. So we have a small test here to track if we are following actually what we have been doing here in terms of questions. And which elements are included with each pillar question in the AWS well-architected framework? Select three. We have A, questions and context, B, best practice area, C, AWS cloud formation, D, answers, E, best practices, and D, design principles. I give like 1 minute for you to read and you answer the questions either on the chat or you shout out the answer. We need 3 of them. Okay, Giselle says ABE. We need a second answer. Edwin says A, D, E. And Maureen says A, B, D. So let's go to the answer. We have questions and context. We have best practice area and we have best practices. So thank you very much, those who answered. So now let's talk about the well-architected tool. So the well-architected framework was a lot of documentation, but we also have the well-architected tool, which you can use in the management console to review your workloads against best practices. And if you go back to what we said that AWS actually released the well-architected tool. I think that was in 2018, right? So this is the tool. This is how the tool looks like in your AWS management console. If we have time at the end of the presentation, we are going to actually log into the management console to see how it looks like live. So what happens here is that this tool gives you quick access to the knowledge in the well-architected framework, and it is the easiest way to conduct a well-architected review. It helps customers to measure the architectures against best practices. And what the tool will do is that it's going to look at your environment and how things are configured in AWS, and it's going to give best practice recommendations. It will tell you exactly what you can change to improve on operational excellence, to improve on security, improve on reliability, cost optimization, performance efficiency, and sustainability. So it actually helps you guide deeper conversations around architectures, and it should not be used as a checklist. How does it work? So the first thing, when you log into your management console, you should be able to define your workloads. And your workloads could be a static website, or it can also be a microservice architecture. And once you define your workloads, then you can start conducting your architectural review. And the third step would be, you would have to, this tool is going to deliver a list of issues found in your workloads and a step-by-step guidance on how you can make these improvements. So there are 3 steps. You define your workloads. The second one, you conduct the review. And then the third one is that this review is going to identify issues. It's going to give you a step-by-step guidance on how you can make improvements. So now, what is the intent of the well-architected framework? The first one is, you should know that it is not an audit. It is about a team working together to figure out how to improve your architectures. And it is not theory. It is a pragmatic, proven advice that AWS has identified through other successful customers. Remember, we said that it keeps evolving. It started in 2012. We had 4 pillars, we had 5 pillars, we had six pillars. And all of these modifications are made because AWS has different experiences, and each time they have to update it. So it's actually something that they have tested. It's not like it's theory. So it's pragmatic. And then it should not be done as a one-time check. It should be a continuous process, completed early and often through your architecture's life cycle. So in cloud computing, there are a lot of changes. The architecture that you have today can be optimal based on what is available, but tomorrow that particular architecture might not be optimal again, because AWS regularly releases new services and tools to do things in a cost-effective way, to do things in a better way, and to do things in an easier way So when you're using the well-architected framework or the well-architected tool, it should be a continuous process because there are changes that you are likely to make in your infrastructure, in your environment, that you need to review and see if they're actually working well. For example, AWS can release a new processor that is very good and much more cost-effective. And if you have an EC2 instance that uses a processor that is not as good and cost-effective as the one that is being advertised, then you are forced to review your architectures. And that is why we say that this well-architected framework is something that you should actually use on a consistent basis. You should be able to measure your architectures against these best practices, identify areas that need improvement, and actually look at what you should be doing in terms of applying the best practices as recommended by AWS. So 3 major aspects when it comes to the intent of the well-architected framework. It is not an audit, it is a pragmatic proven advice, and it is not a one-time check. It has to be consistent. And here again, we have a question. Which attributes describe an AWS well-architected review? Select 2. 1, it is an audit mechanism. 2, it is a pragmatic proven advice that AWS has defined through other successful customers. C, it should only be done once before an application is deployed. D, it can help you identify and implement improvements. E, it has been created after decades of academic research. So what do you think about that? Select 2. So Kinyui says B and D, Divine says B and D. Alvin says B and D, so all of the answers are similar. So let's move to the answer. Okay, Giselle says B and D. So we are good to go. Let's check. Yeah, indeed, it's B and D. I'm happy you're following up. So in terms of the resources and documentations, here we have, where can I find a well-architected framework and white papers? So you can find all the well-architected white papers by clicking on this link. So in total, you're going to have 7 white papers. We have a general white paper for all of the pillars, and then we have 6 white papers for each of those pillars. So we have a white paper for operational excellence. We have a white paper for security, for reliability, for cost optimization, for performance efficiency, and for sustainability. So you can read more by clicking here. So there is documentation, but there are also labs. And find the well-architected framework labs here. So remember that by doing, you learn more. And when you hear something, you will not remember it as well as if you actually do it. So practice, 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 and practice again. And the labs that are recommended for you as cloud practitioners would be the level 100 labs. Again, if I have time, I'm going to log into the management console and show you how it looks like. And then where can I find a well-architected tool? You can sign into your AWS management console to see or to use the tool. So we have come to the end of the session. Now we have questions and answers. Is there any question based on what we have looked at so far before we look at the questions and answers? Are there any questions? Okay.
Is someone indicating the mic to show that, okay, maybe they are getting us? It's so quiet today.
So quiet.
Okay. I think silence means everything is super good.
This is normal. Okay, someone has sent in a message. We are good. Okay, it's explicit. Thanks, Giselle and Alvin. So let's look at the questions. Can someone, I'm not going to read the questions. I think I have 7 questions, so I really need 7 volunteers to read the questions, please. So question 1, who can take that?
Okay, let me take question 1.
Okay, thank you.
Which of the following options help cloud architects build secure, high-performing, resilient, and efficient infrastructure for their applications based on the 6 pillars? A, AWS Security Hub. B, AWS Serverless Application Model. C, AWS Cloud Adoption Framework. D, AWS Well-Architected Framework.
Thank you. So answers, please. So we have D, 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 D. Okay. Okay, let's look at the answer. So yes, it's AWS Well-Architected Framework. So just some little explanations here. So the AWS Security Hub performs security best practice checks. The AWS Serverless Application Model is an open source framework that you can use to deploy serverless applications. And the AWS Cloud Adoption Framework has to do with cloud adoption services. So the correct answer was indeed D. For the second question, please, I need a volunteer. Question 2.
All right, I'll take that one.
Okay.
Says, which of the following are pillars of AWS well-architected framework? Select 2. So it's got A, performance efficiency, 2, B, sustainability, C, agility, D, scalability, and E, high availability.
So thank you. Let's check what's up there. We have AB, and Jian says A. Jian, what is the next? Okay, Giselle says AB. I'm waiting for Diane to come up with the second answer. Indeed, Diane, please. We need 2 answers.
Yeah, still checking what the second is.
Okay. Take your time. At least I heard your voice. Thank you.
It's a tough one for me. I could only identify A.
No problem, Diane. So let's check out the answers, right? Oh, sorry. So we have performance efficiency and sustainability. So Diane, maybe you should think about, the short way of remembering the 6 pillars that we said crops, right? We said crops, whereby C stands for cost optimization, R stands for reliability, O stands for operational excellence, P stands for performance efficiency, S stands for security, and S again stands for sustainability. So if you take a look at these options here, you would see that performance efficiency and sustainability are part of the pillars of the well-architected framework. Agility, scalability, and high availability are not pillars of the well-architected framework. So for the third question, please, I need a volunteer.
Let me read.
Okay, go ahead, please.
Which pillar of the AWS well-architected framework recommends maintaining infrastructure as a code? A, cost optimization. B, security. C, operational excellence. D, performance efficiency.
So Lawi says C, Kinwe says D, Divine says D. Alvin says D. Okay, let's check. Having some difficulties here, sorry. So which pillar of the AWS well-architected framework recommends maintaining infrastructure as code? So the correct answer here is operational excellence. And maybe I should take you back to the pillars for you to see and remember what we discussed about this, because I can clearly see that there's some sort of a confusion between operational excellence and performance efficiency. So let's just go back to the pillars so that you can have a visual image of what it looks like. Oh, what have I done? Sorry. Where did we discuss about that? Okay, sorry. Sorry for that technical hitch. So here we have the operational excellence pillar. And remember, we said one of the design principles would be perform operations as code, right? So that is why the answer to that question is this one, if I'm not mistaken. So let's go back to that question. This was it. So which pillar of the AWS well-architected framework recommends maintaining infrastructure as code? So the right answer is indeed operational excellence. So for the next question, can someone read out this question, please? Is there any volunteer to take this question?
Yes, I'll take it, please.
Okay.
Which of the following cloud design principles support growth in users, traffic, or data size without dropping performance? A, scalability. B, go serverless to reduce compute footprint. C, decouple your components. D, design for failure.
So Edwin says A, Lawi says A, Divine says A, Giselle says A. So thank you. So A is the right answer. And so for the next question, I need a volunteer, please.
I will take that.
Okay, thank you.
Which AWS service will you use to provision the same AWS infrastructure across multiple AWS accounts and regions? A, AWS Ops Works. C, it should be B. B, AWS System Manager. D, Cloud Formation. E, AWS Code Deploy.
So let's look at the answers on the chat. Divine says D, Edwin says D. Who else, please?
The good one, Auntie Yolanda. Let's see if they remember what they did last week.
So Larry says D. Okay. Let's look at the answer. So the answer is D, AWS Cloud Formation. Now let's move to the next question. So question 6. So who can help us read this question?
Which entity ensures?
Let me help with that one again.
All right. I thought somebody was taking that. Okay, let me go on.
Okay.
Which entity ensures that your application on Amazon EC2 always has the right amount of capacity to handle the current traffic demand? A, multiple AZ deployment. B, network load balancer. D, application load balancer. E, auto scaling.
Time for answers on the chat, or you can shout out the answer. So Edwin says E, Giselle says E. Okay, we have 3 E's. Yes, E is the correct answer, but let me just go further, push a little bit further to ask you, why do you think that A is the wrong answer? Why is B the wrong answer, or D the wrong answer? Just to test and see if you understand the different concepts of multi-AZ or a network load balancer or application load balancer. Can anyone just make an attempt to explain why? Because when you're looking at these questions and answers, what actually helps you is that you don't only need to say the answer is this, you should be able to say why the other one is wrong. It's very important. Because sometimes when you are stuck in an exam scenario, you go by elimination. You say, okay, A is not the correct answer because of this, B is not the correct answer because of this. And then at the end of the day, you might end up landing on the correct answer. So let's just try to see, why is A not the correct answer, or B or D? Why did you land on E and not D, or not B, or not A, for example? Can anyone attempt?
Can I try?
Yes, please.
Okay, for A, multiple availability zone deployment. This is to deploy, this assists you to deploy your data in multiple availability zones for security. In case there is a breakdown in one zone, you can still retrieve your data in another zone. That's why I eliminated A. And then for network load balancer, I consider that is to regulate your network. It's in charge of your network, so it's not for traffic. And for application load balancer, I could not really give the definition, but for sure, I knew that it wasn't this. And I took E because auto scaling, it's just, you don't need to apply any manual effort. It just automatically designs the required capacity to sustain the current load.
Resources. Mhm.
Stuck there.
Is that Giselle?
Yes, well.
Oh my God, thank you so much, Giselle. You got it right. So multi-AZ is for reliability, to ensure that when one AZ fails, the other one can pick up that workload. A network load balancer is for traffic distribution, as well as an application load balancer. I'm sure with time you're going to know the differences between the network load balancer and the application load balancer. And of course, the auto scaling is there for you to be able to add or reduce the resources depending on the incoming traffic. So thank you so much, Giselle.
Thank you, ma'am. Thank you.
For the 7th question, so please, I need a volunteer.
I'll do that one.
Okay.
A cloud practitioner would like to deploy identical resources across all regions and accounts using templates while estimating costs. Which AWS service can assist with this task? You go A, Amazon Lightsail, B, AWS Directory Service, D, Amazon Cloud Formation, and E, AWS Code Deploy.
So let's see. Maureen says D, Divine says D. So we can clearly see how important Amazon Cloud Formation is. So if you're leaving this lesson today, I hope you will remember that Cloud Formation is used to deploy your infrastructure as code. It is very, very important. And that was the correct answer here. So Amazon Lightsail is the easiest way to launch and manage a virtual private server with AWS. And B, AWS Directory Service enables your directory-aware workloads and AWS resources to use managed Active Directory in the AWS cloud. And then AWS Code Deploy automates software deployment to a variety of compute services. So we have actually come to the end of this session. I hope you actually had some takeaways. What time did we have? 6. We have just 2 minutes to go. So are there any questions, comments, or?
Let me take the response. Thank you so much for the lesson, Auntie Yolanda.
Even I myself, I did enjoy it. I don't know what about the others, but I personally, I enjoyed it as well.
We enjoyed the class. Sorry that you were silent, but then the class was good. Maybe we were not having questions because the explanation was too explicit. So thank you for that.
Okay. So thank you all so much as well. And remember, as you move on, if you have the opportunity, try to do labs as much as you can, because it's going to actually help you, understand these foundational concepts. Thank you all and have a nice day.